All right, hey everybody. Now I'm going to be talking about what happens when your gear ratio is less than 1, and this is sort of your um, level 3. So how do you earn up to a grade level standard? And the only reason I'm splitting more than 1 and less than 1 for gear ratios is because when the gear ratio is less than 1, it gets a little bit more challenging. Let's put it that way. In reality, can you still plug the numbers into your calculator? Yeah, absolutely. All right. It's just that the gear ratio that we're going to be working with is going to end up being a fraction or a decimal that is less than 1, which makes the rest of the calculations slightly more challenging. Not a lot more, just slightly more. Okay, so in this case, I've just swapped the gears, and I've made the larger gear the driver gear and the smaller gear the driven gear. All right, now to find out the gear ratio, and you are, as always, going to have to forgive my terrible writing with a mouse. But anyway, we're going to do the gear ratio, so we're going to put an equal sign just so we followed this right here. We're looking for the gear ratio, so I'm going to take the driven gear teeth, which is going to be 10, and I'm going to divide that by the driver gear teeth, which is 40, and we're going to get we're going to get one answer. If you plug that into your calculator, you're going to get 0.25. That's our decimal answer. Okay, if you want to go the fraction route and simplify this fraction, you're going to end up with 1 over 4, or 1/4. 0.25 and 1/4 are exactly the same number. Okay, it's just this one is easier to punch into your calculator. This one is a little bit easier if you're trying to understand how the numbers work conceptually, how the relationship works, okay? But again, I always think or plan or calculate using decimal places because you can put this into a calculator and get the answer you need very quickly, all right? But I'm going to be showing you how to use both of these in your calculations. Okay, now, we want to use these gear ratios. We got 1/4 and 0.25, which is exactly the same number. It means the same thing. What you really need to know is that both of these numbers are less than 1, okay? Both of them. 0.25 is less than 1 because on the left side of this decimal place, nothing exists. Even if there was a 0 there, it doesn't matter. It's less than 1, okay? So 0.25 is less than 1. This fraction is less than 1 because the denominator is bigger than the numerator, okay? In both cases, because these are the same number, the gear ratio is less than 1. Now, when a gear ratio is less than 1, we can automatically know some important things about the torque and the speed, okay? Just like in the previous example, when the gear ratio was more than 1, we found out that the driven torque was higher than the driver torque, and the driven speed was lower than the driver speed, okay? In this case, it's just going to be the opposite, all right? I'm making a prediction right now that is going to be supported by the math I'm going to do shortly, which is when you have a gear ratio that is less than 1, the driven torque is going to be lower, and the driven speed is going to be higher than the driver gear. But let's go ahead and prove that. So I'm going to just give some numbers to this driver gear so we have something to put into our equations. And I'm going to use the same numbers as last time because, I'm making this up. So I'm going to say the torque is 10 and the speed, oh, this is tough. Speed, I need a stylus or something. The speed is also going to be 10. Nice round numbers that are easy to use. Okay. So our torque of our driver gear is 10, our speed of our driver gear is 10. Now we can use the number of teeth, we can use the gear ratio, which is over here, to find out the driven torque and the driven speed. So I'm going to put a little t equals here because we're trying to figure this out, and also a sp because, like I said, we're trying to figure this out. Boom. Okay. All right. So driven torque, we're going to go for the torque first. We're going to take the driver torque, which is 10, and we're going to multiply it by the gear ratio. Again, I'm putting in a dot, so times 0.25. All right, so 10 times 0.25 is going to be 2.5. If you don't believe me, open your phone or your iPad and check my work. But 10 times 0.25 is 2.5. Remember, you can also do this the other way, which is multiplying by the fraction, in which case we're going to change this number into a fraction. We're going to change our 0.25 into a fraction, which is 1/4. Again, I'm using the fraction answer over here, and we're going to multiply straight across, giving us 10 divided by 4, or 10/4, which reduces to, put an arrow, 5/2, which is an improper fraction. I think that's what they call it, which we can change to a reduced or a mixed number, which is going to be 2 1/2. Boom, 2 1/2, 2.5, same answer, two different ways to get there. You can plug it in your calculator, or you can struggle with the fraction. Either way, we're getting the same thing. I would say that both these answers are the same. If you wrote these on an assignment, it would be equivalent. Okay. Again, we're kind of trying to find the relationship between these two things, the driver to the driven gear. How does that relationship work? And in this case, the relationship is exactly the same as it was when the gear ratio was greater than 1. You just have to do a little bit more mental gymnastics to understand it, which is the driven torque is 1/4 times the driver torque. Well, it's the same relationship. Remember we talked about last time, the driven torque is also always going to be the gear ratio times the driver torque. So 10 times 1/4 is going to be 2.5, or the driven gear torque is 1/4 the driver gear torque. All right, notice how I can say the driven gear torque is 1/4 the driver gear torque, and I don't actually have to know what the torque is. I just have to know the gear ratio. That's why this fraction is useful. You can make statements, and I'll be honest with you, you're going to be able to figure out test questions way faster, because I'm going to throw some test questions at you that ask you how is the torque going to change when the gear ratio is less than 1, and you shouldn't have to do any math to figure out how it's going to change. You're just going to say, well, since less than 1 means a fraction that looks like this, the torque is going to be less in the driven gear when the gear ratio is less than 1. Right. Now let's do speed. Okay, so now we've got our driver speed, which is 10. Put a little equals sign over here so we know which way we're working. We're going to divide by the gear ratio, which is 0.25, and 10 divided by 0.25 is going to give us this number. Holy moly, Rocky, you say. How do we take 10 divided by a super tiny number, one that's less than 1, and get a number that's bigger? Well, if you don't believe me, you can do the math on your own. Plug 10, hit the divide sign, and then put 0.25 in your calculator. You're going to get 40. All right. We can do this the fraction route, and I'm going to do that down here, which is, if we take the fraction route, which is 10 over 1, and we want to divide by another fraction, we know that when we divide fractions, that's the same as multiplying by the reciprocal. The reciprocal of 1 over 4 is 4 over 1. So if I do 10 over 1 times the reciprocal of 1/4, which is 4 over 1, we're going to get an answer of 10 times 4 is 40. Boom, there's our number, over 1. And that 40 over 1 is the same as this number right here. Holy cow, that's crazy. All right, now, why is this important? Again, I'm going to go back to are you going to use your decimals to do your equations, or are you going to use your fractions? The decimals are going to give you the right answer, so long as you punch the right numbers and signs into your calculator in the right order. It's going to give you the right answer. But it might not help you understand the relationship. Again, you want to be able to say, if I have a gear ratio that is less than 1, how is the torque and the speed going to change? Well, the torque is going to be lower, In fact, it's going to be exactly the fraction lower. So in this case, the gear ratio is 1/4. So the driven torque is going to be 1/4 the driver torque, or it's going to be, yeah, it's going to be 1/4, or in this case, 4 times less. And the speed is going to be the reciprocal of the gear ratio, which in this case is 4/1. The speed is going to be 4 times more, okay, because we're using that reciprocal. Okay, now that's the really important takeaway for you here. All right, can you calculate the driver or the driven torque and speed when the gear ratio is less than 1? Well, that's just knowing which numbers to put into a calculator, and that's just following these equations here. I'm going to put speed as 40. Boom. There we go. All right, but do you know what it's going to be without having to do the math? That's a really important thing. That gives you way more than half of the information that you really need, which is when the gear ratio is less than 1, the torque is going to be lower. In this case, yeah, it's 2.5 is lower than 10. And the speed is going to be higher. Yeah, the speed is higher. Furthermore, the torque is going to be this fraction lower. So the torque is going to be 1/4 the driver torque. And the speed is going to be the reciprocal of that. Well, the reciprocal of 1/4 is 4 times, or just 4/1. And look at this, 40 is 4 times 10. Okay, so we can get to these answers a little bit quicker if we use the fraction side. Again, I prefer to use the decimal side because when things get really complicated, decimals give you the right answer a little bit more clearly, but the fractions help you understand. Okay? All right, those are your 2 lessons on gear ratios.